Good morning or afternoon or night, wherever you are.
Hello, hello.
Welcome to the end of summer community huddle.
Sylvia.
How's it going?
Wonderful.
How's your summer been?
It's been a really good one.
Good.
Sometimes they feel like they flew by. This one felt like it really was a summer. So
Awesome. Well, no better way to kind of end it close to it than with a community huddle. Am I?
I woke up thinking the same thing, Sylvia.
Well, welcome. This is going to be our agenda for today. We have a nice little treat with some release recaps. We have Gianluca and we have David presenting, and then we have our own team doing a compute update. So let's get cracking. Starting with our release. So hop in, peeps.
Yeah. Let me just kind of give a brief word. So we took a break took a break from this in July, and have been. It's been a really productive summer. We've invested in sort of all the layers of the stack to really get our platform in a place where we can serve well the use cases that we have today, and sort of expose the building blocks that we've put in place. And so that's really been all over the kind of the user experience, the portal, datum control, all the way down to literally like the packets that we're moving around in the network. And it's the team has just touched every part of the stack, and it's been really, really fun to do and fun to watch. And so I'm going to let a couple of them share. Kevin, Matt, who wants to go first?
I'll give I can talk a little bit about some
Awesome.
of these. So let's see. I'll just kind of talk all encompassing about all of it, and then Matt can jump in with some pieces as well. I think you kind of talked about it a little bit, where we touched so much stuff in the last couple of months that it's difficult to kind of put all on one slide, but you get the gist here. The onboarding flow, Matt did a great job on completely doing an all new onboarding flow, including the way that we create organizations and billing accounts and projects, the way all of that's handled on the platform, and that comes with a lot, the way that we're doing Stripe and the messaging back and forth, and what happens when you delete an org, and all of the little intricacies that go with just like doing this better is like it can't go unsaid. It's taken us a long time to get it right. There's still going to be things that we have to do, but the onboarding rebuild was like a significant part of July, which ties into the things like billing and usage and RBAC and some of the other stuff that we added into, right? Like we had to add a lot more of our canonical kind of like routing, getting all of these conventions laid out for things like the ALB and DNS and project and organizations, and getting good error pages, stuff like that. And then we dovetailed some of that work into the portal plugin framework, which isn't on this slide, but I think is something that we did accomplish. I meant to add it here, and that is going to allow us to have a module federation based plugin architecture for our portals, both the consumer side and the provider side, which is really exciting. And we already have the first versions of that being brewed with compute and some of the other things that we're doing. What else is on this slide that I can talk to real quick? Is billing mentioned here? No, but the billing stuff I think is a significant one. We have a lot more there too that we've added in the last couple of months, right? Like the quotas is mentioned here, regrouping them by service and giving them readable names, introducing Patch, the assistant, to some of these concepts to make that useful. We shipped the entire billing thing, which is behind a feature flag at the moment, with a dashboards and all sorts of stuff that we're working towards there. And then on the staff side, or on the provider side, we have a lot of these invoicing things and these billing service wired up and ready to go. We're just kind of kicking towards the final pieces of that in this month. So that's stuff that we got done in June and July. we migrated a lot of the stuff in the staff portal to bring that up to the cloud portal standard, as far as like the GraphQL client and the redesign and the assistant and all the other stuff as well. So, yeah, I don't know. Matt, do you want to jump in with anything here?
Yeah, can do. So with the quotas stuff, before we did this like piece of work, you could view your quotas in the cloud portal, but they were just like the raw, like Kubernetes names. So you'd have like gateway.networking.k8s.io/http root or something, which like we know what that means, but an end user doesn't know what that means. So we've just given them their like pretty display names essentially. So we've added some bits in each service where they can declare their display name and description. So it's not all driven from the UI. So things like the CLI can pick them up as well, which was a nice little upgrade. And then, yeah, our user onboarding flow, like we essentially didn't have one before this. So you would just like sign up and then you would just be dropped straight into the portal with like no kind of go and do this or this is what's happened. So we've just updated that so that there's, well, for one now we're taking a payment method, which is like a good step to help us with like fraudulent activity, and then also sets us up for when we bring billing into general availability as well. So users that are already on the platform will already have that kind of stuff set up. They don't need to do anything, which is now nice. And then, yeah, with the AI Edge and DNS portal reliability stuff, was just some user feedback we had, just some small things. Like we were, from the UI specifically, like updating some resources, like just a tad wrong. So it would differ from the CLI to like what you do on the web, which is it's all fixed now, so they act the same. And then the DNS activity stuff is like we have activities set up across all of our resources and all of our services, but they're not very human readable. So there was just an effort here to go in and make sure that, especially on our provider side, if we're trying to support a customer, we know like exactly what they've done in their DNS zone and who's done what and what records they actually updated or deleted or added, and it just makes it a lot easier for us to debug any issues.
Just to give you kind of a view of that, since the staff portal is not viewable to the public. Here's a lot of what the more evidence of the goodness that Matt's talking about. So now we have a much better ability to know our customer and to make sure we're getting the right users on the platform. And then the activity stuff he was just talking about is, well, you probably haven't done anything. You have like 17 different users. Oh, here we go.
Yeah.
So it's just a much more readable, or you were talking about quotas, I think, as well. Yeah. Makes a lot more sense than the GVR kind of Kubernetes.
Yeah, it's just a lot of small quality of life improvements that actually make quite a big difference when you're using the platform day to day.
Yeah, for sure.
Yeah.
As you guys all know, we spent a lot of time with our kind of Milo system of action, and that's what we've kind of consumed here into our operator experience. A lot of what the guys are talking about here is like, oh, cool. Well, anyways, isn't that the stuff you have to do to be a cloud? Like you have to present me pricing and you have to like tell me how much I can use and you have to like, give me reasonable error messages and other things like that. And just building the operational side, because we really believe that, we have to support production level customers and partners who are building clouds and platforms themselves. And so, if we don't have the tools to be able to do that efficiently, we can't be there for our customers. So if any of you are interested in the work we're doing on Milo and want to use similar stuff within your businesses, let us know. That's an area that we think is non-differentiated but super important in delivering any kind of cloud experience. Like, would you like to have a load balancer at the edge of the network? You still got to do all this other stuff. So if anybody's interested in working on that, the team would love to have some partnership contributing and consuming the Milo platform with other cloud use cases.
Yeah, well said, Zach. It's really been fun to build stuff in it because it's tough starting in a complex distributed system like Kubernetes, but once you do, you realize, oh, there's like so many problems that are already solved, and it's actually really, really fun. So please come build with us. That's all we have for the recap. We can go to the next slide. And any feedback or questions on any of that from folks? Okay, cool.
All right, Gianluca, you're up.
Hello.
You might. Yes.
Can you see my slides? They share everything correctly?
Go for it. Yes.
Okay. So yeah, I'm Gianluca. I work with Datum for a few months. Then after a break, we decided to look around and see the state of bare metal provisioning in the open source and not space. Primarily because Datum supports and relies on many open source tools, and the goal here is to figure out if there is one that can fulfill the needs for bare metal provisioning at the speed of Datum. So I started looking at the candidates and see what was available. MAAS, Tinkerbell, old friends we know about. Metal Tree, Foreman, Basker 7, Cedar Omni, Unbounded are the one I selected. Then I look at Netbox briefly, even if it's not for provisioning, because it overlaps with a lot of those tools when it comes to hardware discovery and metadata inventory and all of that. So I was trying to figure out where the overlap was, where the bandwidth, where the guardrails were. So the first things I did, since I tried to categorize all those tools per bucket and identified, the two of them. So I call them the pure bare metal provisioning. That to me means tools that can help you do net booting, DHCP discovery, and all of that. And then you can, the end result is whatever you want. So you can get a Kubernetes cluster, or you can get a Ubuntu machine with SSH enabled, or you can get Windows setup, whatever you want. Then another selection is the one that are tied to Kubernetes. So from the list that I did before, MAAS, Foreman, Tinkerbell, and Basker 7 are the more generalistic one, and Metal Tree, Sidero, and Unbounded are the one that are really like for Kubernetes, let's say. Then I tried to identify the stages that a provisioning mechanism needs to go after, and those are the ones that I identified, at least from a high level. So there is a discovery phase where you have metal that is just in a box, and you need to you mount it in a rack, and you need to identify what it is and what it's made of and all of that. Then you have the onboarding to your inventory. Then you have the inventory, in fact. Then you want to do something with these boxes, so you do a provisioning. And then there is everything that I call day two, that is the life cycle that you want to manage usually for a box. So it's the firmware update, BMC interaction. You maybe want to re-provision another, another operating system on the same box. So you need to do all the power cycling and all of that. And then there is the decommissioning. So this box doesn't work anymore, or I upgraded, so I sold it to somebody else. How do I remove that from my inventory, and how I erase all the data and prepare all the disks and all of that? So those are the phases, and I tried to look for tools that are flexible enough and mature enough to support all of those. When it comes to identifying the technologies that those tools needs to cover, I identified two different, distinct list of technologies. At the beginning of my research, they were a bit overlapping and confusing. So I identified, how how those tools speaks with BMCs and how they can deliver operating systems or workflows into the servers. So with those clear in mind, it was easier to navigate through all the tools to figure out who supported what or who is extensible enough to be able to cover all those technologies. So yeah, and here I did a bit of, summary of who does what and with which technologies. So Tinkerbell supports Redfish and APMI for BMC control and does APXE and DHCP for boot delivery. MAAS does the same and is a bit more flexible in terms of technology that it supports, even if the other tools have hooks to, add whatever you need. Probably the one that is a bit more harder to work with or to expand is Foreman, because of the old history he has, but it is complete as a tool, even if it's a bit old style. Sidero is not, it's open source, but not really open source, let's say. And MAAS is the same because it's canonical oriented. So Basker 7 was interesting because it is a very small pilot project that is Kubernetes native. So it only has support for cluster API. You can only provision Kubernetes cluster and all of that. So it is the extreme lightweight version for Kubernetes, but I don't think this is what we need. I also did a separation about how complex those tools are and how many dependencies they are, and everything you need to run it. So in practice, there are many that needs Kubernetes, and the cool things about, for example, Forkman or Tinkerbell is that they can run as a single binary, and you get everything you need in one binary. So even for if you want this kind of scenario, you can cover it. Then I looked at the communities and the activity and at the licenses to see, since Datum wants to be a friendly partner of those projects and improve them, I wanted to see how friendlier they were. So I tried to submit pull request issues, and I look at some of those to see, obviously some of those goes away straight away, like MAAS and Sidero are backed by Canonical and Sidero itself, so they're not really probably the best one to approach as a company. Metal Tree is really Red Hat oriented, and it requires a lot of OpenStack related technology. It's not very easy to get up and running, and also to get into the community as well. You need to be a bit Red Hat-y, let's say, and also Unbounded, for as much as it is interesting. If your end goal is a Kubernetes node, it is backed by Microsoft. So this leaves with not too many options. So I take another run into how those tools are designed and how they depend or integrate with Kubernetes, because Datum has its own story and its own architecture when it comes to building reliable application, as we know. So I wanted to get to something that was in line with the approach that is already there, and then my recommendation was Tinkerbell or build your own. And in practice, they are not that different, since Tinkerbell comes from, packet host, so it's an old friend, as I say. And build your own is because today, with the speed of LLM agents and all of that, the protocols are clear and well defined, so it's not that crazy to think about something like that if you have a use case that you can translate. And bare metal provisioning is kind of a clear one. So I contributed to Tinkerbell back 5 years ago when I was at Packet Host, so I had to reconnect with the community and with the project, and it changes a lot. It changed a lot in those 5 years. So Jacob is still the main contributors and leading the project. He worked at AWS for a few years, and there is where Tinkerbell changed for the most. AKS everywhere, that is the Kubernetes on-prem Kubernetes service for AWS, relies on Tinkerbell, and during that time there a lot of the project changed there. So if you remember Tinkerbell 4 years ago, it's way different than Tinkerbell today. So today it ships as a Kubernetes Helm chart. So, and it is all made of CRDs, and then it can also be shipped as a single binary. And the trick here is that everything is embedded into the binary itself. So the binary is huge. It's still, I still have to understand how easier to operate it is since it has so many moving parts, but it is a pattern that we all know since K3S and other tools like that relies on the same strategy there. So the components, the main components are the in-memory operating system, the workflow execution engine, the DHCP server and Pixie bootloader, and the BMC integration. So all of those components are in the same binary, but they also have hooks to change some of those. So for example, the in-memory operating system is one of the easiest to swap and replace. So the community also developed different kind and is kind of trying to consolidate to a new one. The features that I like the most other than the one that you will expect from a bare metal provisioner are the auto discovery. So as I explained before, you hook your servers into a rack, you plug the network, and then they show up in your Tinkerbell because there is an agent that goes there and identifies all the hardware and a few metadata that it tells you what it is. So you can create templates and workflows for future provisioning. And they made some work on the BMC library and integration to have serial over SSH. So I think that's a neat one to have. Static layer 3 provisioning. If you don't have a DHCP, you don't want one along the way in this part of the provisioning step. And as I said before, everything turned to be a CRD, so a custom resource definition. So it is Kubernetes oriented. So you get all the benefits of that we all know since we know Datum. So you get the kubectl, you get the client Go, you get all the event and reconciliation controller that you that I think proved to be reliable and helpful. And then there is a cluster API support, so you can get Kubernetes up and running on top of a Tinkerbell installation pretty easily with all the cluster API standards that we're used to. It also got a read-only, at least at the moment, UI that shows you all the resources available, and you can see the machines, and you can see the templates and all of that. So I'm saying read-only at the moment because I suppose that there are a few community pull requests that are pending to make it also writable, and I think it will be soon done, let's say. A few items in the roadmap are from the official one is IPv6 and DHCP-v6 support. It already supports some of it, but it's not end-to-end, it's not first class. So I think that's the idea, is to get only IPv6 if you want. And improve operational experience, having tracing and consolidating on the metrics. So all the OpenTelemetry support that we expect. So you can see a trace coming from the first iPixie booth, and then when the in-memory operating system starts, then all the workflow job execution till the server is ready to go. I think that would be interesting to see and very helpful when it comes to troubleshooting. And they are working on a new in-memory operating system that supports low resources boards like Raspberry Pi and all of that. So because now the one they have now is too big to run into Raspberry Pi, so they are trying to shrink it and support more boards. And that's it.
That's great. Thanks so much, Gianluca. Probably wondering why we're talking about bare metal provisioning at a network company. We are very quickly getting hardware in places. We've got 3 network POPs that we're building in DataBank, and we've got some data center space in Quebec that we're building out. We've got 64 GPUs headed there very soon. And so we are expanding our footprint rapidly, and that comes with all the fun of automating everything all the way down to the silicon. So this is, Gianluca's been helping us kind of get up to speed on what's been going on since we've been living in software only land for several months now. So thank you so much, Gianluca, for helping us.
Yeah, this is great, man. And just to give it a little bit more context, we've got 3 POPs you guys may have seen that we're deploying in databank locations. Those are on physical hardware to run not only our networking stack that will, put you through here, our kind of layer 7 edge, and also our upcoming kind of micro VM compute product. So we'll put more of those. The plan is to go into the 30 or 40 places around the world where the internet meets, and deploy our own edge capacity, which we got to be good at turning on and off and all kinds of computers. They're getting more interesting by the day.
Indeed.
Yeah, look, this is great to see. Appreciate you diving in.
Yeah, thank you. It was a pleasure.
As I've been telling my wife for about 25 years, she asked me what I do. I'm like, well, just go turn on computers and turn them off again and try and boot them one more time. It's basically what we do.
Yeah, I need to admit that BMC integration and firmware updates, it's still the nightmare for all the issues I see there. So not much change there, I suppose.
That's great. Well, thanks again. Well, we're super excited to show you all our progress on Galactic VPC. And our little fun vehicle for exposing that is, by the way, this little micro VM platform based on Unikraft, which is super exciting for us because we want to connect things together. In case you're not familiar with Galactic, if you're new here, essentially it is the layer 7 meet me room. It's connect all the things everywhere and do it in a way that infrastructure and software developers can easily do it. So we want to abstract all that hard networking stuff that you need to do private connectivity and predictable pathing and all the things that really are not available to software developers because, hey, you're probably building on a cloud platform, and those cloud platforms, really don't want to talk to other platforms. They want to make networking easy only in their environments, which makes sense. It's really hard to make it easier across. So that's where we come in, and it's really hard to see or touch a network. You got to have something to do with it. And so we partnered with our friends at Unikraft, who have been deep in the unikernel space for years and years, and PhDs and all the things that we're not going to do. And we've been integrating their product into our stack, and that has been a really fun process. Actually, it's taken less time than I thought it would take, to be honest. We've hit several interesting hurdles along the way, and they've been great to work with, knocking those down. And so we have some functioning product here to show you. There's still a lot to do, but we can show you the progress. Who would be best, Peter, Scott?
So I can get us started here.
Yeah, thanks.
Yeah, I can get us started for sure. So hey folks, so I did a thing. So let's talk about that thing that I did, and it's kind of exciting. So if you're going to build a cloud scalable network in 2026, you're going to start with IPv6. And more importantly, you're going to start with IPv6 by building a SRV6 fabric. So we talked
Peter, why are you going to start with SRV? Why are you going to start with IPv6? Come on, man.
So
we can't let you just take these big statements and run with it.
So the reality is without getting into all of the technical minutia, the reality is, if you didn't know this is where the world is going, this is where the world is going. IPv6 has been around for, at this point, going on more than 20 years. And it really was designed to solve the challenge of all the things on the internet. I'm gonna just kind of leave it at that big global statement. All the things.
So we have like a address, issue, but there's also
we have an address issue. We have a very serious address issue. Right.
Missing header space and ability to do stuff with IP that people would then have to like build all kinds of weird overlays and weird stuff on top of to deal with, right? Because the internet went from can we just trust each other and connect some addresses and route some packets into like, the foundation of our modern world.
there is no doubt we have spent, entire verticals within our industry have sprung up over the last 20 years that are purely dedicated to doing exactly what Zach just said. And that is, how do I build overlay technologies so that I can stave off having to readdress my infrastructure? And a lot of that is predicated by applications struggling to be able to adapt to an IPv6 world. And so at some point though, we've got to kind of cut the cord. And so when we looked at this thing, we said, the cord cutting time is now. It is now. It was probably a few years ago, but no one has been bold enough to say it needs to be now. And that's really kind of where we started our infrastructure is IPv6.
And to give the lay of the land, sorry, I'm going to go into like why now, because I tried to in 2014 start Packet with an IPv6 only network. Yeah, because I was like cheap and didn't want to buy V4 address space and a variety of other things. And it turns out it was not possible for a ton of reasons.
That's right.
But like now we have over, I think in the US now, it's something like 55% of IP traffic is V6. Mobile networks, which is the primary path for most people on the internet, like daily hours logged, et cetera, is almost exclusively kind of V6. And the Linux kernel, right? Like along with most, kind of the routers that drive the internet have data planes that are very kind of V6 efficient at this point, right? So like, I'm going to say that like we have the foundations now that 10 years ago we didn't, because like moving on to the IPv6 internet was a lonely place to regardless of whether you're presenting V6 as your routing, like there was just not enough connectivity and substrate and adoption to make it really, kind of a content capable network. Yeah.
That's 100% correct. 100% correct. And, but it creates an interesting dilemma. So while it's not as bad as it was, when you tried this the first time, right? The challenge now is that we still need all the things, right? We still need all the things to operationalize applications that run on an IPv6 fabric. And as we have learned in the last 3 months or so, all the things is a very small. It's a very small number of things, which means that we ended up building a lot of it, on our own. And so I'm going to take you through a little bit of what we've done just in the last 30 days or so in order to do this. So, about a month or so ago, I guess.
Can I interrupt one more time? Sorry, Peter, because our visions are like we're early, but and Peter's been doing the hard work of making things talk to each other in scale cloud primitive ways. But the two real reasons, why do we care about V6 is our substrate for this kind of galactic networking, inter-cloud networking capability. Kind of number one, being able to introduce, kind of some of the subnetting and routing capabilities that we can do with V6, where we can understand versus basically RFC 918, private, internally addressable only space. We envision that having addressable space that can be effectively ACL'd off from the world, but can then be used publicly and interchange with other people is really important, because we have a large amount of address space and can use kind of V6 sublot or whatever they're called. They're not called subnets. They're called somebody help me out here, but blocks in an efficient way. Okay. The second thing that can be routed efficiently in the data plane. And the second thing is really because we envision the need for policy. Okay. And, SRV6, which is where, this kind of use of additional header space to add, tags and policy really allows us to do source-based routing. And instead of then overlaying MPLS on top of IP to be able to say this backbone link needs to connect to this one in this path, right? We're able to do that with policy in natively on IPv6, okay? And that's the real superpower, because we want to help give people without having to build their own fabric or like overlay, backbone, the ability to control their traffic and to add some like source base, or like, hey, when it goes through here, I want it to stay in this cloud, or go to this next hop, or go here next. And that's like the super fundamental way that we're like, could we prove that IPv6 as a foundation and SRV6 as our kind of mechanism for adding policy, is it mature enough for us to be able to do that? Sorry, that was my soapbox. It was like, from the business why, like, why do we give a shit?
It's all good.
Yeah.
It's all good.
All right.
So with that backdrop, Zach and Drew and team asked me to go build this thing. Okay, great. Let's build it. Interesting thing happened along the way, though, is that you start to realize that there's still a lot of componentry that just flat out needs to be built in the industry. And so we've spent a lot of time building a lot of the pieces and parts ultimately necessary to deliver on this vision. So, for example, over the last, if anyone's been watching the Galactic repo, Datum Cloud's Galactic repo on GitHub, one of the things you'll have noticed in the last 45 days or so is that we've introduced a number of eBPF applications now that allow us to operate in the fast path in Linux for the sole purpose of being able to transition from segment routing headers to microSIDs. Okay, a lot of fancy terms. Let's break that down into something that's a little bit more digestible. One of the challenges that IPv6 has always had, and very specifically segment routing within IPv6 has always had, is not conceptual, it's been technical implementation. In the technical implementation, to do exactly what Zach just alluded to, is the fact that we would start to stack headers in IPv6 world. Okay, well, the problem when you start stacking headers is that you're taking up very valuable space, meaning that I've got less space to actually transmit data because I'm taking all that up with header information. So if I want to build a set of headers that say I want to take a very specific path through a network, maybe that says, I want to go from the East Coast of the US to the West Coast of the US, but I only want you to take a southern route, right? Those are things we can technically do, but doing that with SRV6 meant that we were putting all of these different headers, because what we were doing is we were actually embedding policy directly into the fabric of the network. We weren't relying on external controllers. We weren't relying on external programming. We weren't relying on somebody to try and figure this out with least cost routing. We were actually embedding that policy right into the network infrastructure itself. And by embedding it into the network infrastructure, what it allows us to do is it allows us to be very adaptive to how we ultimately want to move traffic from any 2 points in the infrastructure. I can move traffic in Europe by I can say I want to go from, France to China, but I don't ever want to go across Russia, as an example. For whatever reason, and I don't care what the reason is, but we can start to embed that in there. So one of the key things that we did in Galactic is we introduced a way to now do that through microSIDs. A microSID just simply says, I'm going to take all those source route headers, I'm going to collapse them down into a very defined 128 bits. By doing so, I can install those 128 bits directly in the fast path in my infrastructure, meaning that I don't have to traverse up and down the entire Linux stack. I can now install them at a driver level, at a NIC level, as an eBPF XDP application that allows me to simply read and forward at line rate. So we did that, and that was a big step in the right direction. The next thing that we needed to tackle is, now that we have a microSID infrastructure, an SRV6 microSID infrastructure, we need to figure out, how do you put load balancing on top of this thing? And this is what I spent the last month or so, actually, over the time of my summer doing. So this is what I want to share with you a little bit, because this is going to be the key enabler that's going to allow us to start to actually attach applications to an SRV6 or an IPv6 fabric. And so let me start with get my share going here, and hopefully you all can see this. And what you're looking at right now is you're looking at a deployment that's built into the Galactic repo. So anybody out there can actually bring this down. If you have the Container Lab binary installed, you can actually turn this up today, and you can actually see this working. So you don't have to take my word for it, because believe me, don't take my word for it. You know, install it yourself and make it happen. But what we did is we now have VPCs that can actually talk across our SRV6 fabric. This is a mirror of actually what we're building in production. And so it allows us to actually test with this, validate this, and actually use it in a way that it would actually be used in production. So I can actually see the IPv6 fabric that's delivered by our fabric router. I can see the SRV6 fabric, which is defined, and then I can actually see the microSIDs that allow, say, VPC NS10 to talk to VPC NS10 over here. Now that's all over private IPv6 ULA or effectively the equivalent of RFC 1918 addressing, meaning it's not available on the public internet. So no one can get to this stuff, right? It's all very private right now. So then we took the next step, and the next step was a very critical step for us. We said, you know, what we need to do is we need to front end our VPC technology with some type of gateway functionality. And so what we did is we built new technology, and we did a lot of looking in the infrastructure world. And we said, you know, does this actually exist today? What we were actually looking for is we're looking for a layer 4 load balancer that actually natively worked with SRV6 using microSIDs that provides us massive scalability because it operates in the fast path within Linux, i.e. XDP. Surprisingly, there's almost nothing out there in the public domain that exists today. We looked at tools like Cotron, we looked at tools like Cilium, we looked at tools like LoxyLB, and while a lot of them do different pieces of them, none of them natively interoperate with SRV6. So we bit the bullet, we said, you know what, we're going to write our own, and we did. So this is a whole set of PRs that are going to post later today to Galactic. You're actually going to be the first folks that have seen this, but we've actually built this today. It now allows us to build a load balancer that sits on top of an SRV fabric so that we can do policy steering at the fabric level. We can do load balancing at the front end so that we can stretch across our surface area for things like DDoS attacks. And then we can horizontally scale our Galactic gateway, which is the piece that we just defined. So now when we have a web client that comes into Datum's network, it can come in, it can hit one of a number of gateways in the emulation or in the lab environments, 2 gateways, pick one. It will then translate that to the SRV6 or the IPv6 fabric, pass that across RV6 fabric to land on a worker node ultimately, which will then just simply say, okay, I understand by looking at your IP destination address, I know that you belong to a very particular VER for a very particular VPC. So I'm going to unwrap it, I'm going to send it into the VPC, and then the VPC can then respond directly without having to go back through this path directly to the client. So that's actually what we're going to look at right now. And the way we're going to do this is, give me one moment while I share my next screen. My safe place, the terminal. Everybody, well, networking people like me, this is my safe place if you don't know. But so we've defined a new CRD. This is now part of Datum's network, and it's actually now part of Datum Cloud, which is, of course, anyone can take a look at. And so now we can define a backend address, FD20, 60 FF03 100. That is a private IP address that is not routable on the public internet. But what we're now saying is we're going to expose backend port 80 to an external port 80 over TCP, and we're going to give it a VIP address of 2001 DB8 6060:1. In essence, what I'm saying here is that I'm just simply saying, hey, I've got a VPC. The VPC is running private address space. I'm now going to expose specifically only port 80 as port 80, and I'm going to make it publicly available. So then now from a client side, as you can see, I can just simply do an HTTP curl, 2001 DB8 6060:1. Okay, well, that all matches. And when I don't have a fat finger, I can actually see the web page coming back to me. Okay? So what you've just looked at, and this is a very key point, because there is no other technology that is available today that's actually doing this. We're the first that are actually delivering this in the open source domain. And that is back to
It's possible. All things are possible on the internet. We may not
all
know.
things are possible. All things are possible.
Here,
What
you
I
can
just
tell us,
simply
right? If you found it on the internet.
So what I've just done from TR4 is I sent a curl request that routed over the public internet, public infrastructure to TR3, that hit one of my two gateways. That gateway then said, to talk to you, go to VPC NS60. NS60 serviced the request and then returned it back to my client on TR4. And that's actually what you just saw me do. So for the first time, we have a layer 4 load balancer natively integrated with an SRV fabric for doing traffic steering for the purposes of exposing an application to the public infrastructure. And I will stop there. And
Peter, does that DSR, like, does it go straight back or does it go back through the network?
It actually goes back. Well, I mean, it always goes back through the network. But the point being, as you see it here, right, it is a direct reply. It's a DSR reply. We're not going back.
It is a DSR reply. Okay, cool. Okay.
It is absolutely a DSR reply. 100% a DSR reply.
Neat.
Peter, can you say a little bit about how, like, what is the like when you use internet transport for that? What's happening just from an in-cap to cap perspective? Like, is it just writing on L7 SSL? Is there other stuff going on there, other magic?
Yeah, no, that's a great question. So this is purely an L4 data path. This has nothing to do with layer 7 right now. This is not a proxy. This is truly a L4 data path, or an L3 data path in my world, right through the infrastructure. So when that client made the request on port 80 and we actually hit the gateway, all that gateway is actually doing is it's simply checking to say, okay, you're asking me to talk to a service on port 80 on a specific IP address. And what I'm going to do is I'm going to drop that onto this SRV6 fabric, right? And remember, going back to our previous conversation, within the SRV6 fabric, I can now add policy. So while what you see right here is just a simple routing demo, imagine this now in a full production infrastructure where we've got global nodes across the world. And I'm exposing my little application down here on port 80, right? I can actually, as we start to introduce more and more functionality to Galactic Gateway, I can now actually introduce policy directly within the fabric of my network that makes very conscious decisions about how I get from my ingress point to my application. I can make decisions like always ride the public infrastructure because I don't want to pay the extra cost. Or more importantly, this is a mission critical business continuity application that I want to make certain is always on an SLA backed set of links. These are all types of things that I can actually embed now directly in the infrastructure and let it ride that. Just as importantly, and I think that the real key, the real thing we unlocked here was really right here. And for my networking friends out there, right, for my networking nerds out there, you'll appreciate this, because what we've done is we said, hey, I could always do this, right? I could always build this in a network stack, right? I can go up and down the stack all day long and make this happen. But what we did is we made the very conscious decision to build this as an eBPF application that leverages XDP, Express Data Path. What that means is that the way that Galactic actually works is it's making all of these decisions at the lowest level in the stack that it possibly can. It's not allocating buffers. It's not interrupting CPU cycles. It's not taking a lot of processing time to make the decision that, oh, I need to go from A to Z. And that is a really key point to actually how this works. Every other solution out there is either trying to terminate the connection and build a second one, i.e. proxy, which isn't bad, but it comes with some trade-offs, right? But we're not actually doing it. Or B, I can actually run it up and down the stack, and we're not doing this in this case. We're actually dropping it right onto the SRV fabric.
Cool.
So I hope I hit your question.
Yeah. Yeah, so it's like it's more like tunneling, I guess, right? Like if you had like a GRE tunnel between
it's not tunneling. That's
okay.
that's
what I'm trying to.
It's not tunneling at all. Yeah, okay. It's not tunneling. This is not using Geneve. This isn't using IP and IP. This isn't using GRE. This is natively taking a public request, dropping it onto an SRV fabric, policy routing it to its destination, and then returning it back to the client. So we don't incur all that overhead that tunneling brings. So this is as IPv6 native as you possibly can get in the public infrastructure.
Great, thanks. I think that's the biggest point that, especially for non-networking people to understand.
Quick question. Is it hashing on the 5 tuple to get to the gateway?
It is, absolutely. In fact, it's actually, not only is it hashing on 5 tuple, but it's hashing on 5 tuple plus VERF ID.
Okay.
And that was the big change that there's plenty of load balancing solutions, layer 4 load balancing solutions that do 5 tuple hashing. That was never the problem. The problem with 5 tuple hashing is the fact you can't have overlapping address space.
Yes.
Right, which means it precludes VERFs, VPCs, etc.
For sure.
That is what we developed, is we now have the ability to include VERF ID as part of that hashing. So now we add VERF ID to that. And that was the big change here.
Great. Thank you. And we can potentially switch hashing mechanisms, choose them, right? Later.
Oh, for sure. Yeah. Now that we've written the code, I mean, we can do anything we want with this. I mean, we can go in all kinds of directions, whether it's building out a infrastructure that is policy routed based on educational reasons or performance reasons or cost reasons or application priority reasons. We now have the ability to do that. More importantly, because this is all happening at layer 4, and it's actually technically a layer 3 transit underneath it. It allows our customers ultimately to build applications that aren't specifically tied to just purely HTTP, right? And so now, we can build an infrastructure that allows organizations to attach applications to it or build applications on our platform that can operate at really any layers within the stack, sans layer 1 and 2.
So are you saying that you can program that fabric box there, the mesh, the UCID mesh? Are you saying that you could program that to kind of control access or like return price? Like if you were doing like a paper crawl, like the internet's kind of moving to this paper crawl model where like if it's an agent, it's going to return a price, and if it'll pay the price, and it'll go that way, and you can kind of control whether or not like things can access certain resources, or this resource costs money if an agent uses it. Like, do you feel like this is going to be part of that? Like that's where that type of programming will be able to take place right here in this diagram, essentially, instead.
Yeah, it absolutely can be. Yeah, it absolutely can be.
That's really interesting.
I think more importantly, in today's hyper, in today's world where we're hyper concerned about things like data sovereignty, where we're very concerned about cost, where we're very concerned about data accessibility, I guess that's same as data sovereignty, right? Is that we can now program this infrastructure in a way that meets our needs and our goals. We're no longer succumbing to, hey, I bought infrastructure from a company, and however I get from point A to B is no longer anything that I can really control without paying a super premium and building very expensive private links between everything I'm trying to do. What we've done is we've now created all of the knobs, and we're going to give you all the knobs that say, hey, if you're operating in Germany and you need to make sure that all your data always stays in Germany, bar none, you can actually program our fabric to do that. And we expose all of that capability.
I mean, this is where we'd love to work with other partners. So, obviously Datum's going to go and build a backbone capability to deploy this across, most of the places, and hopefully give you all great high-speed, economical connectivity substrate that you can start to program and control. But people are going to want to put in places we don't. And so any kind of IPv6 native network or capable network should be kind of Galactic compatible, right? And so this is open source. It is not MIT or Apache currently. It's AGPL. But we're open discussions around that so that more people can adopt this capability and extend what we think is kind of curated, managed connectivity in between different counterparties or for their own purposes. The area that I think we could use to work on over time is like really simplifying the policy tag mechanism or working together as a community. So that way things like what Peter just said, like let's say there's a new, which I fully expect to happen, some new EU directive or like France law that says you have to like connect in these ways. Like how could we make that so that it's like, instead of custom routing config, it's basically like, you know, a policy definition that you can subscribe to, right? And like that would be really cool, right? Because then we can work as a community and across, you know, different parts of the internet to support what we feel is kind of a, you know, increasing complexity in what we all have to do as service providers. So if you have interest in working on that, or you have customers who might care about where and how they're sending their packets or having to comply with things around that, that would be really awesome to work with you all. Thanks, Peter. This is great. Just slinging packets,
Thanks,
man.
Love it. It's what I do.
Hi, Peter. This is Avoy. I joined this call for the first time. Thanks to Manish to introduce me. I have a question. So, your solution is lying on top of HTTP. Now, how is it going to play with real ASIC underlying, right? Like say a Tomahawk, for example, right?
Yeah.
How is it going to play the role? I assume like Tomahawk can give better performance than HTTP.
Yeah, no, fair question. So one of the things that we've been very careful of as we've developed Galactic is we have a very specific separation between how we define the capabilities of what Galactic can do versus what the implementation actually looks like. So, and I think this is a very important point. Galactic is defined as a set of constructs and a set of capabilities that can be deployed or ultimately built to be deployed on any infrastructure. Now, for our cloud infrastructure, we're actually building it on top of our Kubernetes deployment that's actually leveraging a number of different technologies underneath the hood. But nothing stops anybody from taking kind of the concept, including the gateway, including Galactic Router, including everything that it's doing, and writing the very specific provider that would lay it onto a big iron box if you want to go that route, right? If you wanted to connect to, say, you know, an Arista EOS switch or a Juniper Juno switch or, you know, a Cisco switch or that. Yeah, exactly. So in our particular, and let me just call this up real quick, and I apologize, give me just one.
And we've done some data plane work, which is specifically around like Bluefield. We're working with Excite, you know, people who have basically Linux interfaces to their networking offload. So it looks like a big ass Linux kernel to us, right? But it's very possible there is more specialty silicon.
That's right. And that's what I want to show is right here. This shows that shows this very example, and never mind some of the stuff over here. It's still just stuff we're still building, but I wanted to show you this right now. Is that this is what you're looking at working today. You can pull this down from our repo. You can validate all of this right now today. But the way that it's constructed is we actually have the ability through Zebra, if we want, we can actually bring, say, a Bluefield 3 DPU in here, or I could bring a Excite DPU into here, or I could actually get rid of Zebra and I could change this to, say, I could turn this into a number of different programming interfaces, and instead of programming Linux Rib, I could be programming, like I said, you know, in a Cisco switch or an Arista switch or whatever the case is. So, or I could plug this into Sonic if I really wanted to, right? I've got a lot of different options here, but we've been very diligent about keeping that line of separation in place so that the functionality lives independent of its implementation.
Okay, sounds good. Thank you.
Yeah, and I will say, like, Datum's main interest is to be on Linux boxes. You know, we will certainly leverage, and Shelby, like, we got big iron switches with nice ASICs to do, you know, internet routes sitting above us, and we expect to have those. They're really super good at them. But this level of functionality that we want to do, because, like, we envision, you know, kind of like thousands or tens of thousands or millions of Galactic networks, many of which won't do like huge amounts of traffic, some of which just want to have policy and control. So the focus has been on Linux, and then separately like Linux capable offload NICs. But like I could see somebody caring about, you know, an ASIC as well.
Yeah, and just to kind of put a fine tooth point on that, and I think this is super important. I know we're going to run out of time here a little bit, but as somebody who has built networks, global scale networks, all of my career, one of the challenges that we've always had is the fact that we keep trying to bolt all this functionality onto ASIC driven deployment. And when you look at what we've done with Galactic, is that now Galactic is actually embedded in the fabric of how we're actually delivering the service. So whether you're actually, programming a Bluefield 3 DPU, or I'm programming a Tomahawk, or I'm programming a Jericho, or name your favorite ASIC, I don't care what it is. Right? The point being is that we've now brought this functionality directly into the fabric of the infrastructure. I'm now programming it in such a way that it meets my needs. I'm not trying to figure out a way to bolt it on later. And that's the $1 million point in my mind.
I know we're at time, but I have a follow-up question. How are we handling the telemetry, right? How are we pulling the stats and states from the data path and making it huge, on our controller like Galactic to make sure that our intents are always met? Is there anything you have in kind of implemented or thinking about that in the future?
Yeah, so from the Galactic perspective, we expose tons of metrics, coming out of Galactic. Now, what you do with that metric information, obviously, is not up to Galactic. That's a higher end system. And
Right.
Without putting Michael on the spot, I'm gonna put Michael on the spot. I don't know if you want to add a little bit
Got a
to
great
some of the work that
diagram
you're
he
doing
wants
right
to
now.
show everybody.
No, maybe the diagram for another time. But to Peter's point, we're going to expose whatever metrics we need, and anything that we're exposing here. This is because everything that we're doing is being done in the public. We want to make these metrics universally useful. But the philosophy that we're generally taking is to speak everything using OpenTelemetry's OTLP. And so we put everything in that format for us to be able to do standard metrics collection, metrics writing. So very Prometheus friendly. Same thing with logging and tracing as well.
Thank you.
Does that answer your question, Avoy?
Yes, it did. Yeah, thank you very much.
Yeah, in general, we want to lean into standards, and then if we have to do something weird because of practical realities, then we'll definitely do it. But it's been great to have so much good technology out there to build upon. And we're excited to have you build with us. Just a quick note about what's coming up, more of the same. We're constantly, finding issues in the platform and chasing alerts and just making everything overall more production ready. And as we, get Galactic more operational and fully operational, it'll be, I'm sure we'll find some good stuff there as well. So please use the platform. It's all open. It's free. It really helps us out because it puts real traffic through there. And I mean, we certainly, can we do our own load testing and regression testing, but nothing beats real users. So we would love to have you beat up on the platform as much as you can. And if you need, once you do find issues, please just find us on Discord or open a GitHub discussion or anything. There's lots of ways to get a hold of us. You can email support@datum.net if you can't think of anything else. That's all we got.
There we go.
Great. Well, thank you guys so much for joining. This was amazing. And we'll see you at the next one.
Catch you in the fall. Enjoy the rest of your summer, y'all.
Yeah. Ciao.
Thank you.